Hi guys, this is Rational versus Irrational, page 2. I'm really missing you guys today. This has been tough, but we're gonna soldier on here. Okay, Joseph wants to find the side length of a square that has an area of 150 feet. Should the answer be rational or irrational? Why? So if the area is 150, the side length is going to be square root of 150. And the square root of 150 is irrational because 150 is not a perfect square. So this is irrational. Which of the following list of numbers is not a rational number? Okay, so a rational number can be written as a fraction. We'll just write that over here for now. Rational can be written as a fraction. Smiley face. Okay, so 8.224, this is 8. This is the tenths place, the hundredths place, the thousandths place. This is 8 and 224 over 1,000. This can be written as a fraction. This is a rational number, so this is not the answer. 5/9 can be written as a fraction. So this is a rational number, so it's not part of our answer. Square root of 25. Square root of 25 is 5, which is 5 over 1. Can be written as a fraction, so it is rational. 0.321 repeating. Any repeating decimal is rational, so this is rational. This is not rational. Oops, it's supposed to be an arrow. Not rational. Because 30 is not a perfect square. If you're struggling with your perfect squares, it's not a bad idea to just write them. Whoops, sorry, that's supposed to be green. It's not a bad idea to just make a list. So you can just refer to it. 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, 6 squared 36, 7 squared 49, and you can look at that 30 and see if it's on your perfect squares list. Nope. So you know it's not a perfect square. So use that perfect squares list. Brad converted 5/11ths to a decimal, and his result was a repeating decimal. Does that mean that the value is rational or irrational? Rational. Because it can be written as a fraction. So this one, that's our tenths place. I'll say this says state whether the given values are rational or irrational. Tenths, hundredths, thousands, 10,000ths. This is 3 and 4, 5, 6, 7 over 10,000. This is rational. These ones we don't do. That's irrational, I guess. And this is a repeating decimal. Any repeating decimal is rational. Let's see, I'm gonna erase that and scroll up. State whether the given values are rational or irrational. So if we remember our perfect squares list, 5 squared is 25, that's supposed to be an equals. 6 squared is 36. So square root of 30 is irrational. So 6 plus the square root of 30 is also going to be irrational because it has a square root of 30 in it. Square root of 6 plus 30, the square root is a grouping symbol. So square root of 6 plus 30 is kind of like has parentheses here. You have to do under the grouping symbol first. So this is square root of 36, bing, bing, which is 6. So this is rational. If the plus is not in the square root sign, there's no grouping symbol here. So this is an irrational number plus an irrational number. You're going to get an irrational number there. An example of an irrational number that is greater than 10. You can do the square root of any number greater than 100. Because square root of 100 is 10. So you have to have something bigger than that. Or you could say something like 10 pi. That would also be rational. I'm sorry, irrational. 10 times. Nope, 100 pi. Sorry. No greater than 10. 10 pi would do it. Oh my God. Sorry, guys. 10 pi would do it. I'm tired. It's nighttime and it's been a long day. All right. Love you guys. Miss you. Hope you're well. Page 3 coming up.